Okay, guys. So let's get started with Hive, and we will see how this whole Hive stuff goes. And so what all we are going to cover in terms of Hive is, guys, is we are going to cover what Hive is and where to use Hive. Right. So we'll understand, what Hive is, what is the Hive architecture. That's what we are going to understand, and we'll understand also a scenario where we can use that. Then what we will next understand is like why to go for Hive when we have the pig that basically makes our life easier. Then why again we are using Hive. So we'll see the difference between that. And then as I told, like Hive architecture, different components of Hive, little bit background about Hive, like from where it is started, the whole journey of Hive, and how the Facebook uses Hive, like why something became so different in the environment that they came up with this particular tool. So we'll understand that as well. And then we'll see a lot of Hive query language and difference between the normal RDBMS and different types of the data type it supports, and the hands-on exercise. With the help of this particular slide, we'll understand the whole journey of Hive, how it is started. Okay, so the whole journey of this Hive is started from the Facebook. So when Facebook started initially, they had a smaller data set, like few GB of the data. That's where they were getting in 2006. But slowly, all these Web 2.0, all these social media kind of the website becoming very popular, they started seeing the flood of the data which started coming to their internal server, the data collection server which they had. So initially, they were using this Oracle kind of the database to capture this database and analyze basically the user behavior, because their whole, the Facebook stuff, what you see, it whole service it generates from like what you do on that particular page. Right. So they had this particular requirement where they wanted to capture all the user activity, and based on that, they wanted to analyze the data set and then come up with the recommendation or the services for each user. So what they did is, instead of having Oracle, because Oracle was not able to scale in terms of the requirement which they had for the data. So in that particular stuff, they started moving towards having a big data kind of the solution, and that's where the Facebook became one of the early adopter of this whole Hadoop platform. And when they started using this particular Hadoop stack to have the storage of the data, so they faced a couple of challenges while doing that. So they had like huge number of the user base which they were serving, and terabytes of the data per day, and a lot of the SQLs which they wanted to run on top of that, the analysis which they wanted to do. And along with like all these user activity data, they had a lot of unstructured data, like image data as well. People are used to upload on the Facebook site. So this was the challenge what they had in terms of the kind of the data which they were getting, and that's where this whole traditional RDBMS was not suitable kind of storing this data, this kind of the data, and processing such huge volume of the data. And the kind of solution they got to handle this kind of the data set was the the Hadoop MapReduce job. So basically, having Hadoop kind of storage and the MapReduce kind of the processing, they were able to process the huge data set which they were getting from their weblogs, and they can now process that with the help of Hadoop. Now, in terms of the technology, Hadoop was a technology like which can store the data and process the huge volume of data in parallel. That's what we understood till now with our interaction with the Hadoop. But then the challenge what it has is like, for the users is, so they had the people who were very good in terms of the SQL. So they had the people who were very good understanding of like how to process the data by writing by a SQL query. But the kind of the data set which they have, that data was available in Hadoop in kind of infrastructure. And if you have to process anything inside Hadoop, it has to happen as a kind of a MapReduce code. So this was kind of, a challenging task for them to basically convert their requirement into the MapReduce job. So it becomes like very hard for them to program directly in the MapReduce, because the skill set what they had for the people who were expert in analyzing all this web data is SQL kind of interface. So that's where what Facebook did is Facebook analyzed this particular situation, and what they come up with is like there is a kind of a gap between the kind of expertise they had and the kind of the tools they have to use to basically do the programming. And that's where they come up with something, a project called Hive. So what the Hive did is it basically provided a SQL kind of interface, and by using that you write your whole processing or whole logic in a SQL construct, and that will get translated into something called a MapReduce job, and that will run on top of Hadoop. So by having this Hive mechanism, what they were able, or Hive tool, what they are able to do is they are able to match the gap here. So you write your requirement in the SQL, and that get converted inside for Hadoop, it get converted into a MapReduce job with the help of Hive. So that's what the Hive became a kind of a tool for using a SQL interface on top of Hadoop. And one interesting thing, guys, this particular challenge, like, so then obvious question will come, like when we were developing Hive, why Pig came, right? So the reason why you see these two kind of innovation, Hive and the Pig, it basically both happen in-house. So Hive was developed inside Facebook, while Pig was developed at the Yahoo. So when Yahoo was facing this challenge of, like, again same converting into the MapReduce job, they come up with a language called Pig, and that's what their users were using to convert into the MapReduce job. What Facebook went is more easier approach. They come up with a SQL interface, and then that getting converted into the Hadoop MapReduce. So what you have in Hive is you have like Hive. You can create tables. You can create database. I will show you like how to do that. You can just read the data. You can create partition and the buckets so that you can restructure your data set and you can process that. It has a lot of the schema flexibility, so you can alter the table, you can move the columns, and you don't need to basically reload the whole data set. So all those things easily you can do all these schema flexibility there with Hive. Then apart from like whatever the Hive offers its own, it also have the plugin custom mapper in the reduce code. So at any point, if you have a requirement to write your own custom code, you can easily write that and can integrate with Hive. And the next thing what you have with the Hive is the JDBC ODBC driver. So nowadays, all of these vendors, be it any reporting tool, MicroStrategy, Tableau, like whichever you are using, they have connectors available to Hive. So by using this JDBC ODBC connection, you can easily, read the data which is available in Hive. Although it's like high latency query, it takes some time to read the data from Hive, but you can read the data from Hive and you can process it. Or you can see or visualize the data in your reporting tool, right? And in terms of the table creation in Hive, you can create your table. Like if your data is stored inside the Hadoop file system, you can just create a Hive table on top of that, and you can start processing the data with the Hive SQL. So that makes your life much easier. You don't need to basically go through a lot of the load process and all as you have in the normal ETL. You can refer the data and you can start using that. And apart from that, Hive also supports a different kind of the formats, like it has the RC format table. You can store the data in sequence file, right? So all those kind of the, there are different, the optimization kind of stuff you can do with the Hive in terms of storing the data and processing with the help of Hive query language. So this is the example, guys. Again, like so in Hadoop, one thing what you have to understand is like you have the multiple way to do the same thing inside Hadoop. You decide like which particular tool or which particular approach you want to do based on the your comfort level, based on the expertise which you have, and as per that you will start processing your data inside Hadoop with that particular tool. So as we can see this healthcare example, it can be done as the Java MapReduce code. You can write directly a Java code. You can do that. You can do this in Pig. You can process that, or you can use this Hive interface again with the Hive as well. You can read the data in Hive table, do all this, de-identification or encryption of the data you want, and you can store it inside the Hadoop file system. So what the Hive is basically a data warehousing package that's built on top of Hadoop. So you get a kind of all this data warehousing function. You can create database, you can create table, you can create view, you can read the data. So all those kind of operation you can do with on top of Hive. And mainly used for the data analysis, the people who are from the SQL background, business analyst, your data analyst. So they prefer to go with Hive because you can easily use the existing SQL expertise to start interacting with Hive. And mainly targeted towards the user who are more comfortable with the SQL kind of interface, so they can easily use that. And similar to kind of the SQL and call, it's generally like you have the SQL, it supports a lot of functionality. In case of Hive, it's not everything what you have in the SQL it supports in Hive query language, but it has good compatibility with like what the SQL interface you have. And generally used for managing and querying the structured data. So this is like one of the important thing you have to understand with the Hive, because Hive may look easier to you, but then it has one of the kind of the constant, and that's generally like it can process only the structured data. If your data is unstructured data or semi-structured data, you will not be able to process with the help of Hive. Okay. And then the other thing what it does, it basically hides the complexity on top of Hadoop. So now you are not writing the code directly with the help of the MapReduce, but you are writing in something, the language which you are familiar with, the SQL kind of the language, and then that gets converted into the Hadoop MapReduce job. And as per the history of this Hive, so it was developed at the Facebook. So as you can see, it was developed at the Facebook, and they contributed it back to the Apache open source. And it's one of the the tool that's widely used inside the Hadoop stack for accessing the data, analyzing the data. And as the Facebook was the main contributor for this particular whole project, Facebook claims that they analyze like there are several terabytes of the data every day with the help of the Hive interface. So that's the kind of the uses of Hive, and the kind of the background you have for the Hive, how it is started. Okay. So now let's look something more about the Hive, right? And when I'm telling about Hive, although it looks very promising in terms of the interface it provides you to process the data, but then it has some kind of limitation as well. So one of the things is structured data. Then the next thing, what I will tell you that what Hive is not, you will understand like what Hive cannot do that. So let's first understand like what all Hive is, right? So the Hive is it's the kind of the data warehouse infrastructure. You create database, table, view, and then you access the data. So that's the kind of the interface it provides you on top of Hadoop. Easy way to basically enable ETL kind of operation, so you can easily aggregate your data, summarize your data as you do in normal ETL processing. Now with the Hive, you can do that. Okay. Then what you have to interact with the Hive is a SQL kind of the interface. So that's like most of the people are familiar with that, so that you can use it to basically analyze the data and interact with your data. And apart from whatever it offers as part of the native form of Hive, it also allows the programmer to basically plug in the custom mapper and the reducer code. So with the help of your custom map and the reduce code, you can basically always enhance this whole Hive functionality in terms of the processing or to meeting any kind of a particular business requirement which you have. So where all you can use Hive? So as like one of the thing, Hive is generally suitable for the structured data. So whenever you have a structured data set, you can easily use Hive for that. So like if you have the log and if you want to process that, you can do that. If you have any kind of the the customer facing BI solution, like where user can tell, okay, can you run this particular SQL and give me the count of these users in this particular geo. The next requirement is going to do, can you tell me like what all the top 10 customer in this particular product category, right? So all those customer facing kind of the business intelligence you can easily you can do with with the help of the Hive. You will be, once you expose your data with the help of Hive, you can easily write SQL and query that. Any kind of the data mining, if you want to do that, you can use that as well, right? So you can analyze your huge data set with the help of the Hive SQL. Any kind of the indexing you want to build, any kind of the predictive modeling where you want to fetch the data. So for all these purpose, you can use Hive to basically select the data and feed it to the other algorithm which it has. So now, why to go for Hive when Pig is there, right? So that's like one question what you might be getting, right? When we saw something similar kind of the feature, now why we are talking about Hive, right? So when you talk about Hive, it generally exposes your data with in form of the SQL. So anytime if you have to provide this kind of the SQL interface, you can use Hive because your data can be represented in table in the column format. When it comes to the Pig, it provides something similar, like you can declare like what you want to do and then Pig will be able to do, but you will never be able to access the Pig data set in terms of a table or writing a SQL. So it will be always direct interaction with the files where the data is getting stored or file where the data is getting read, right? And generally the Pig is preferred by the programmers and the researcher who likes to basically do all the programming stuff and do the stuff their own. While in case of the Hive, it generally used by the analyst, which can who can easily analyze the data with the help of Hive. Now, compared to Hive and Pig, if you want to have the more understanding, so let's see some few more features with Hive and the Pig. So one is Hive, it provides you the SQL kind of the interface. So that's what you have the SQL kind of look and feel when you interact with the Hive. But while in case of Pig, what you have is you have a kind of a Pig Latin language, and that's where you write your code and interact with the Pig compiler, and then it converts the whole your program into MapReduce job. In case of the Hive schema, yes, you have to provide the schema how you want to read the data set. Until you provide the schema, it will not be able to read the data. So you have to do this create table, give the schema, then load the data inside that. In case of the Pig, what you have is it's basically the implicit, guys. So if you want to give the schema, you can use this as keyword and you can give the schema. But if you don't want to use the schema, you can leave it as it is, and then with the dollar notation, you can always access Pig. In case of Hive, I will show you like what is partitioning. So Hive supports partitioning, so you can get basically you can do some tuning in terms of the processing of the data set, and it will be faster. While in case of the Pig, there is no the partition as such, so you store either all the data set to a output directory. Pig has a support of the thrift, so by using this thrift API call, you can query this Hive meta store, and you can see all the details about this, the Hive tables and all from this, thrift API call. In terms of the UDF, user-defined function, both of them support, and most of these UDFs will be in Java, so that's what they support. serialize and deserialize, and both Hive and the Pig supports the serialize and deserialize. DFS direct access, yes, you can read the data directly from the Hive as well as the Pig. You can both, the data set can be stored inside the Hadoop file system, it can be there. In terms of the shell, you have this both Hive and the Pig shell, so both have their own interactive shell which you can use it to interact with the data set which you have. And both have this streaming support as well, and the interface, Hive has a web interface where you can see the data set, see the table, all those kind of stuff, but then Pig doesn't have any such interface. In terms of JDBC ODBC connectivity, in Hive, yes, you have this ODBC connectivity, but in case Pig, it will just write the data inside the output file, and then you have to move that file with the help of whatever tool you have, and then integrate it. So let's see some quick architecture stuff like Hive, how it looks and how it processes the data set. So in case of the Hive, your data is going to store inside the Hadoop file system, right? So that's the location where your data will be either stored or you're going to store as part of your Hive table load. And the reason why you store your data inside the Hadoop file system, because that's the place you get basically the reliability and the scalability stuff. So by using this Hadoop file system, you will be able to have all these multiple copy of the data that you can replicate across the server and you can consume that. So that's what the HDFS offers. In terms of the Hive, so that's about the storage of the data part. And then what you have is you have the something called the meta store. So what the meta store means is whenever you create a Hive table or create a database or the view, all those definition about the data set, the database which you have created, the table you have created, all those things will be stored inside something called the meta store. And on top of this meta store only, you have this Thrift API call running, and that basically enables you to do browse, query with the help of the JDBC and ODBC connectivity. So your all table definition, column definition, database, everything will be stored in something called the meta store. Now, when it comes to the meta store, you can implement meta store in different way. We are going to see a slide for that. For our lab example, what we are doing. So generally, with the Hadoop installation, what you have is for Hive, there is a Derby database. So that's where your meta store will be stored. But you can take that out and you can start, putting your data on a MySQL and other kind of the database as well. The challenge what you will have with the Derby database, guys, is it's limited to one user only. So at one point, if you have moved the data, only one shell you can open and then you can interact with that. Apart from that, what you have is like all these user-defined function support. So it supports all these MapReduce script. You can integrate that. All these, the UDF function, string, sum, average, those kind of things you can do. If you want to basically read serialization and deserialization data, all those kind of the data set it can support. It can support all these comma separated file, regular expression, all those kind of the processing you can do with the Hive. Then in terms of the storage, what a Hive has it's supposed text file, like you can store your backend data in the text file itself, so you can read the data set. If you want to store your data as a sequence file, you can do that as well. If you want to store data in RC file, so RC file is basically, guys, a columnar way to store the data inside the Hive. So if you are using just selective columns in the rest of the Hive processing, you can define your Hive table in such a way that it will store the data into the RC file format. Okay. So the different components which we have for Hive. So we have one thing is we have is Hive shell. So by using the Hive shell, only we are going to interact like how the Hive, create tables and all those stuff. Then you have the Hive meta store. So what the meta store does is it stores the metadata about the Hive. So all it will have is the table definition, view definition, database definition, all those kind of things will be stored in the meta store. Then you have the Hive cell, we talk like where we submit the query. Then you have something called the driver. So with the help of the Hive driver, it will take your code and it will convert into the, into something which Hadoop can understand in terms of execution. And then you have the Hive compiler, execution engine, optimizer. So all these basically, whenever you submit your query, all these steps, go through this, the compilation and execution, and then finally you will have the output that will be basically a MapReduce job that you will be running inside the Hadoop cluster. So as I was telling about the metastore, guys, so you have the option like you can use the embedded metastore. So whenever you install Hive, it also comes with a metastore. So if you want to use that, so that particular metastore is in Derby, and that's what the metastore we have in our virtual machine as well. So with the help of this metastore, you will be able to store all your the database and table, all the definition, right? All those things you can store in this particular metastore. Now, when it comes to like going beyond the Derby, because in the Derby you can have only one command line interface, and that's what you can run. So in case if you want to have more, you have to go with the MySQL. When it comes to MySQL, you can store locally on the machine wherever the Hive is running, or you can run on the remote machine as well, and then provides that connectivity to that meta store. So now we talked about Hive. We see that Hive can, do a lot of good thing in terms of giving SQL interface and all. But then there are certain limitations as well we have with Hive, right? And which Hive cannot do that. So let's try to understand that as well, and then we'll basically switch over to see some more concept, and then basically the Hive hands-on kind of stuff. So limitation of the Hive. In Hive, there is no selective update and delete kind of operation. So like if you talk about the normal Oracle or the SQL interface, where you insert the data, you update the data and delete the data based on the row key. In case of the Hive, that's not the kind of the requirement. So if you have like any selective update or delete to be performed, that particular stuff you cannot do with the help of the Hive. Then the other thing is, like, when it comes to the Hive performance, I don't want to basically oversell Hive. What I am trying to tell you is Hive is good in terms of the SQL kind of interface which it provides, but then it's not good for basically high low latency kind of the query, because it has its own process to convert your job, run the MapReduce job, and then get the output. So that particular stuff, it takes time, and it's not very the faster kind of a process. That's what we have. And it has the latency for the Hive queries is generally very high, so you will get basically high kind of the latency whenever you are interacting with the Hive dataset. And since it doesn't provide the selective update or the insert, so it is not basically designed for any kind of the online transaction processing kind of systems. Now, what all you can do with the Hive, guys, or with the Hive query language? With the Hive, you will be able to filter the data, like it's suppose all these where clause and all. So with this, you will be able to filter the data. You will be able to join the data set. So some of all these things, I will show you guys in Hive hands-on as well. So you can store your data into a Hadoop file system, like from the Hive table. If you run certain SQL and you want to store in Hadoop, you can do that. And it also supports something called the partitioning, guys. So with the help of the partitioning, what you will see is it basically speed up the process of how you read the data and consume the data. So if the person who is responsible for creating the table, if knows that how this table is getting to be curated, you can basically partition the table, and based on that, it will be able to be just read that particular subset of the data. Yeah, and also in Hive, like you can read the data set from one table, and it will be able to move the data to other table as well. So you can do create a table as select, and then it will be able to do that. So okay, so before I go further, guys, there are a couple of more slides as well, and then we have the data model partitioning and bucketing. So at this point, guys, shall we switch over to the hands-on stuff? Let's see how to interact with the Hive, how it stores the data, what is the structure, and then come back and see like what is partitioning, what is bucketing, and then with that one, right?